Hi everybody, welcome to our movie Shadow Plots, a first look. We actually took our shadow plots that we've worked with before when we found altitude, our shadow plot from 910, and we actually put a little toothpick right there and messed around with a flashlight to see if we could mimic these points, and everybody of course found out that they could. And something we've really already seen a number of you guys do, it said draw the motion the flashlight goes through to mimic the sun. So in other words, to make those, what we found is if we make this the ground right here, that the sun or the flashlight had to go through an arch motion to make that pattern of dots. And we've seen that before, that kind of arching motion that the sun makes as it comes up and goes down. And then the second question was, does the path of the sun that you just drew have a line of symmetry? And if so, draw it in. And what's special about the sun at this point? Well, it has a line of symmetry basically right at the highest point that goes right down the middle of it. I, of course, couldn't draw it absolutely perfectly freehand, but it does have a line of symmetry. This half can just fold right over on that half. And then it says, for 3, do the shadow points on your plot support the drawing you made in question 1? Well, let's look at it. What this tells us is that we have a line of symmetry here. We have a very low sun in the morning and afternoon, and a very high sun in the middle of the day. And of course, that's exactly what our shadow plots show. At the beginning of the day and the end of the day, our shadows are really long. And we know a long shadow means a low light source or a low sun. As we go through the morning, the sun gets higher and higher until it reaches a highest point during the day. And then all of a sudden, those shadows start getting longer and longer again. And so the correct answer on this, of course, was, yeah, it does agree with those for the reasons I just mentioned. And then it says, about what time of day did the sun reach its highest point? What evidence do you have from this on your shadow plot? Well, of course, our highest light source is going to be producing our shortest shadow of the day, because high light sources make short shadows. So if we go to here and we look on our line, we say, well, where was the shortest shadow of the day? And it's going to be somewhere right in here, in the middle of our day. Now, we weren't necessarily out making a point right at that shortest shadow of the day, but we'll learn later on how to find that. So about what time of the day did the sun reach its highest point? A good estimate would be, let's say right in between here, probably around 1 o'clock would be about the highest. But you could have said 12:40 and you could have said 1:30, and those would have been perfectly fine answers as well. Now this one was kind of a toughie. We had to get our shadow plots out for this. Shadow plots can't be started at exactly sunrise or sunset. Explain why this is true. And the easiest way to explain why this is true is with a drawing. So if we think of the Earth as this curved surface, is what it is, and we think of a gnomon right here, when the sun is first coming up, it looks like it's right on the horizon over here. Well, the problem with that is our straight lines of light, which I'm drawing freehand, sorry, are going to come here, and they're going to make a shadow that looks like this. It will never, ever even hit the Earth. So, of course, we can't make a point on the shadow plot because the tip of the shadow isn't even going to hit the Earth. In order for a shadow plot to make a point, the sun has to get up to a certain height so it, let me do it better this time, so that it can, I may not even have it enough this time, so that it can have a point, and you see I kind of missed it, but you get the idea, so it can actually make a point on the shadow plot. So on this one, the first one I made was at 7:40 a.m., but the sun came up well before then. So that was a little bit of a toughie. Next one. What does the shadow plot tell you about the location of the sun when it was made? Draw a sketch to illustrate your answer, and I said from a bird's eye view. Well, what that means is simply this. If you have a shadow plot, let's make some dots here that represent a shadow plot. If you have a shadow plot, then the shadow right here is like a reverse pointer to the sun. So if we make this, we'll take our ruler, I'm going to go ahead and make a dashed line here showing the light coming in from the sun, and then go ahead and make the shadow that would make. But light travels in a straight line. We found that out. So again, the shadow is always going to be a reverse pointer for the sun. And then it said, make a line that connects all the dots on the shadow plot. Do not connect them just dot to dot. Just draw a freehand line goes through the points. Now what we're looking at was this, to try and just smoothly connect all of our points with a nice kind of little flowing line like that. That's what you would want on your shadow plot. I better come out a little bit so we can see the whole paper. So that's what we were looking at there. And then it says, do all the shadows cast during day fall on this line? And the answer would be, we didn't go out and put a dot in at every point of the day, but if I gave you the world's most boring assignment and I said, put a dot out every 30 seconds, every dot would fall on this line. Because think of why we wouldn't all of a sudden have a random dot that would appear up here. That would make all of a sudden the shadow go from getting shorter, shorter, shorter as the sun comes up, to a moment where it gets really long, which would mean the sun all of a sudden darted down before it came back up again. So on this particular one, every single shadow plot point during the day, even the ones that we didn't get, are going to fall on this line someplace. 9 o'clock would have been probably right around, like right there, even though we didn't make a spot for it. And then, does the shadow plot have a line of symmetry? If so, where about is it? Well, it's going to be right at the same place as the one we drew. That's our shortest shadow of the day, gives our ecliptic, which is what we call this line, it gives it its line of symmetry. Well, our shortest shadow of the day on our shadow plot is going to also be roughly where our shortest shadow of the day is. And if we do this, and we fold it along this line, you can see that the shadow plot lines pretty much line up side to side. Now they're not the same length either side because we can't make the shadow plot that way, but all shadow plots have a line of symmetry and it goes right through that shortest shadow of the day. And then it said there are times not listed on the shadow plots, those before 7:40 and after 6:30. Draw on your shadow plot where you think 7:10 a.m. would be and where 7 p.m. would be. What we would want to do is we wouldn't want to do this and say that's 7 a.m. And sometimes people like to do that because they think of the sun coming up, but that doesn't make sense with our line. It makes no sense that we have this very gradual line and then all of a sudden it dips down right there. We're going to come out like this, keep the line consistent, and 7 p.m. would probably be like right over here, and 6:30 late in the day, at 7 p.m. would be the same thing. We would just extend this straight out and probably go 7 p.m. right there. Okay? And you need to write on that for that. And if we made a 3-season shadow plot from 3 months from the time this was made, do you think it would look the same? Now, this is just kind of an on-your-own question. I'm not going to answer that on this, but just try and think about whether it would look the same or not and what would be some things that would tell you about that. So that's our first look at shadow plots. And, of course, if you're watching this too, you're going to need to download the shadow plot for this as well. All right, thanks for watching.